Okay, this week we are looking at graphs of rational expressions. So first thing we're going to do is go back and kind of remember listing excluded values. So we need to factor what's on the denominator first, and then we can go ahead and list your excluded values. Your denominator is a difference of perfect squares, so that leaves us with x minus 3 and x plus 3. So for our excluded values, we're going to set both of those equal to 0. And then solve. So x can't equal 3 and x can't equal a negative 3. Okay, that should be a quick review. We can keep simplifying, cancel those out. So you are left with 1 over x minus 3 as your final answer, as long as x doesn't equal 3 or negative 3. Okay, so we are going to focus on finding the asymptotes and wholes of a rational function. So you will need to go back to kind of what we did in the very beginning of the year to remember what a rational function graph looks like. Okay, here we have this off to the left actually solving it like we've been practicing the last few weeks. But where we have that x does not equal 1, you'll notice that there's this vertical asymptote is what that's called, or an imaginary line that red graph is never going to cross. So we're going to actually find how to figure that out and solving for that stuff today. So your discontinuities are where you have your excluded values. That's where you're looking at your denominator and setting those equal to 0. They are instances where the function is undefined, so values that x cannot equal. We have two different types of discontinuities. Vertical asymptotes, which is that vertical line, and then holes in the graph as well. So a vertical asymptote is a vertical line that the graph approaches but never actually reaches. Where your denominator equals 0 and the numerator does not. Okay, so that's kind of a key point as we're remembering this stuff. A hole in the graph is another place where it's also undefined, but that's going to be a specific point in the graph that the function does not exist, so you can't have a value at that point, and you get holes in your graph when you cancel out a common factor. Okay, so make sure that you guys write this down so that you can see this as we go to solve some of these examples. Okay, so here we have our first example. We're going to look at the graph for this one as well. But let's do what we've been practicing in the past and actually solve this one. So first thing we need to do when we're solving is we need to factor. So again, we're seeing what numbers will multiply to that negative 2. And then add up to a positive 1. So we need a positive 2 and a negative 1. So our factors then become x minus 1 on the top, then we have x plus 2, and we have an x minus 1. So go ahead and list your excluded values. So x plus 2 equals 0, and x minus 1 equals 0, and we're going to solve for x. So x can't equal 1, and x can't equal a negative 2. Okay, so we've done that before, excluded values. Now we're going to cancel out terms. Okay, so we've been practicing this as well. We can cancel out the x minus 1, so you are left with 1 over x plus 2. Okay, from the vocab on the last two slides, we saw that if there's a discontinuity or a value that you can't have, and then you cancel out that term, that becomes a hole in your graph. So just here at the bottom with our excluded values, at x equals 1, there's a hole in your graph. Any other discontinuity, so any other value that you have that you can't cancel out, is going to be a vertical asymptote. So we couldn't cancel out that x plus 2 factor here on the denominator. So that value, that becomes a vertical asymptote. Okay, so we're just going to list those. Now let's go through and try to graph these. I think the easiest to do is your vertical asymptote first. So at negative 2, you're just going to have a dashed vertical line. That means your graph cannot cross at that point. To figure out your y value of the hole, okay, so we already said that x can't equal 1. We're going to plug 1 into your function. So our new function is 1 over x plus 2. We're going to plug 1 in for x. and whatever value you get is going to be the y value for the whole. So we have a whole at 1, 1/3. So we're going to plot that as well. 1/3 is going to be right around there. Okay, and then we are going to actually graph our rational function. So we have a rational function that looks like that, and that looks like this. Okay, the main things I want you to focus on are that purple line, the vertical asymptote, and then the hole in your graph as well. Those happen from our discontinuities. Okay, here's another example. I'll do this one with you guys, and then for the next one, I want you guys to pause and try it on your own. So first thing we want to do is figure out discontinuities, so we need to factor. You have a difference of perfect squares in the denominator, so one is plus, one is minus. We're going to list our excluded values over to the side. So we have two values, x can't equal -5 and x can't equal 5. We need to figure out which one, if any, will be a whole and which one will be a vertical asymptote. So now that we've listed your excluded values, you can cancel anything. I noticed that we can cancel this x plus 5. So wherever we originally had that factor, that's going to be a whole in your graph. Then we're going to simplify this function. You have 1 over x minus 5. So that factor, because we can't cancel it, that's going to be your vertical asymptote. Okay, let's figure out the y value now for your whole in the graph. Okay, so our new function is 1 over x minus 5. We know that your x value for the whole is going to be -5. So we are going to plug that in for x. That leaves us with 1 over -10. That's your y value for the graph. So this will be a whole. And then x can't equal 5, that's a vertical asymptote. So there is going to be a vertical asymptote at x equals 5. Your vertical asymptote is always going to be a line, and it's going to be x equals whatever that line is, okay, because that's going to be an imaginary line that your graph cannot cross. Okay, so same type of things that you've been practicing with simplifying and canceling out rational expressions, but now we're combining all of those in order to look at the graphs and pick out the characteristics of those graphs. So for this one, I want you to go ahead and factor this, list your excluded values, see if you can figure out the whole, find your x and y value for the whole, and see if you can label what the vertical asymptote would be for this one as well. So go ahead and pause this video here, try this on your own. And then in a little bit, go ahead, you can unpause this and check and see if you got the answers right. So hopefully you paused the video and tried this on your own. This should be what you had gotten for your final answer. Okay, you did not have any holes in this graph because you had two factors of x plus 1. Okay, so x cannot equal 1. Because you couldn't cancel anything out, that means there's just going to be a vertical asymptote at x equals -1. Sometimes you will get that. Sometimes you won't have a hole in the graph. Sometimes you won't have a vertical asymptote either. Okay? So just pay attention to that. Go back to the vocab for vertical asymptotes and holes. Okay, what I want you to do for a Google form quiz, there's not a worksheet with this one. Your next video will introduce a little bit more characteristics of graphs with rational functions. So we're going to combine this video and the next video for the worksheet. But I do want you to fill out a Google form where you are going to give just a quick explanation of the process that was explained in the video. So you're explaining it in your own words, okay? Just a few sentences, does not need to be a page long, and submit that on the Google form quiz. You should not have to submit a picture for this quiz. You could just type it all. So go ahead and do that. Let me know if you have any questions. We're not going to have scheduled Google Hangout meetings, but if you need to, we can set one up. Hope you guys have a great day, and you will hear from me soon.